How are you, everybody who is watching this video? I would like to take this opportunity and welcome some physical ordinary diploma students who are actually have joined in this class in order to enjoy about the maintenance of the radar and navigation aids, or just the maintenance in communication engineering system or telecommunication engineering system, or just in mechatronics engineering systems and different systems where that we have to do the maintenance. My name is Olenjolai. I thank God for the gift of teaching and gift of being electronics and telecommunication engineer. I used to be an informal and a formal teacher. One thing which I want to tell you that I don't know everything. I just know small portions of what I'm responsible to teach. This is the actual series or a sequence of the lectures that we had actual from lecture 0, and now we're in lecture 11. So lecture 11 is actual our lecture number 12, because we started with lecture 0 as well as we are electronics and telecommunication engineering students who we actually believe on number 0, because usual number 0 is not the counting. We usually count from 1, but when it comes for the digital, just the matter of 0 and the 1. So we'll be focusing on maintenance, and this is the common steps, and actually it's a critical and it's very important topic for all the technicians, because the one of the primary functions of the technicians is actual to maintain different equipments and different systems. So I hope that you are ready and you are well prepared for this class. I would like to ask you to join me and stay connected, but make sure that you ask questions in order for you to be a part of this class. Today we are going to learn about common steps and tools for the troubleshooting radar system. But remember that this is just the name, one of the electronics communication system. You may replace it, common steps and tools for troubleshooting mobile phone. You may just have a title, common steps and tools for troubleshooting maybe a radio receiver. You may also have common steps and tools for troubleshooting the car engine. Common steps and tools for troubleshooting maybe the particular transmitter or electronic communications transmitter. So actually that's what you should have in your mind, and you should expect it a lot, because we are going to have we'll be writing much, but we'll be writing technical information. So how are you, students? How are you, students? Yes. Are you ready for workshop 11? Yeah. Well, so let us go to the business. So let us start with quick review. This is the second lecture with regards to 40 of maintenance. Quick review of lecture what? Lecture 10. So in lecture 10, first of all, we learned the meaning of the maintenance. What is maintenance? Maintenance is the process of what? Maintenance is the process of what? Yafari, maintenance is the process of what? This is the function of the table. Why don't you use it? Maintenance is the process of what? Pardon? It's a set of who? Process. Okay. And then we discussed the meanings of the word troubleshooting. Troubleshooting. Isaac say troubleshooting. Are you Isaac? Isaac say troubleshooting. What is troubleshooting? Okay. Then we learned about some examples. Examples of what? Of maintenance. Examples of maintenance. Then we learned about, after learning the examples of maintenance, then we discussed together two main types of what? Of maintenance. The first one is what? Preventive maintenance. We call it PM. The second one is what? Corrective maintenance. So what is the difference between them? Preventive maintenance. So this is the type of maintenance done. Pardon? Temporary. Done regularly. And daily what? Or by following what? Routine or schedule. So this one we say that is usually done before what? Before the equipment or device fail to operate. And then we say that in radar systems we are using preventive maintenance rather than corrective what? Maintenance. Why? Because radar system and navigation aids are the real-time system, which they are supposed to work all the time. Okay? In case we want to do corrective maintenance for the radar systems or navigation aids, we should have a pair of system. So when one will be operating, the other ones will be in standby mode. And once we visited TCAA, they have been explaining about that, and they told us the necessity or the importance of having what? Pair. And then we discussed about the other types of what? Of maintenance. So how many other types of maintenance do you mention? 5. The first one? Determined. Predetermined. So predetermined what? Maintenance. The next one? Condition-based maintenance. The next one? Reactive. Predictive maintenance. Reactive or reactive? Reactive. Reactive what? Maintenance. So today, let us focus, and then also we presented in this way in that lecture that radar systems also have some common problems, which is actual face them and make them failure to work or to give wrong result. So let us pay attention to the common steps and tools. So in case you missed lecture 11, you can access them, or you can access it in our official YouTube channel. So common steps and tools. Common steps and tools. Remember that I told you the word troubleshooting and maintenance, they have closely meaning. They have closely meaning. So common steps and tools for troubleshooting radar system or troubleshooting multi-electronics communication system. So he said that radar system and the navigation aids equipments experience different technical problems. So these radar system and navigation aids equipments experience different technical problems. So let me mention some of them. Some of their common problems. Some of the common problems that may affect a radar system one of the common problems radar system may have a problem of interference. Say interference. Say interference. So ask yourself what the meanings of interference. This is one of the common problems that facing radar system. The second common problem is noise. Say noise. For instance, who likes noise? Who likes noise in this class? Do you like noise? Jafari like noise? So can we make noise in order to make sure that we encourage Jafari? Yes. Make noise for Jafari. Noise. Then the third common problem is called the calibration. The radar system might have a problem of calibration. Say calibration. Calibration. Ask your neighbor, are you calibrated or not? Are you calibrated? Then the second one, the first common problems is called the alignment. Say alignment. Alignment. Say alignment. Alignment. So it means that radar system may have a common problems of alignment. Then the fifth common problem is called the synchronization. Say synchronization. Say synchronization. So the fifth common problem is called the synchronization. The sixth common problems, it can have power system, can have radar system can have a problems of power. Say power. Then the seventh common problems is also radar system can have a signal quality problem issues. So radar systems can face the signal quality issues. Then, because I found 7 common problems, you have to find the 8th one, the 9th, and the 10th. So fill the blanks. So at least you must know 10 common problems of radar system. So in order to keep this information on mind for the rest of our life, let us pronounce these 7 common problems of radar system, then we move to the next stage. Neema. So now it's the time for all the class. Stop writing. Let us mention. Say interference. Interference. Then say calibration. Calibration. Alignment. Synchronization. Or synchronization. Power. Signal quality. Among these 7 problems, which one did the technicians of TCRA presented to us? Sorry, which one among these 7 common problems of the radar system, which one among these 7, which one did the TCAA technicians present to us as their common problems, or the common problems that our Tanzanian radar system experienced? Which one? And I'm very unhappy that no any students asked me about that question. So wait, I will ask you. Yes, because you just found the Doppler pulse primary radar and the secondary surveillance radar. You just found them. And there's one thing which I was actually surprised. From the beginning to the end, you did not ask the common problems. You saw that those instruments or those equipments actually do not face any problem. And that's not the mind of the technician. The mind of the technicians, regardless of how the system is operating, the next concept that the technicians wants to hear about the common problems and how to fix them. Okay? So do you see that what you have been missing? Noise, yeah? Okay. So the following are the common steps that are followed to troubleshoot radar system, or other electronics communication system. The first stage of troubleshooting, of maintaining electronics communications or electronic system, the first stage, it's just like the first step of 7 steps of solving a scientific problem. So identify the problem. In secondary education, we've learned 7 steps that you have to follow on solving scientific problem. Do you remember? Yeah? The first step is operating air. The second step, hypothesis formulation. The third step, experimentation. The fourth step, holiness, data analysis, data collection. The fifth step, data analysis. Very good. Then the sixth step, data interpretations and representation. Then the 7th step, conclusion. So even in troubleshooting and maintaining the system, the first step to identify the problem. Once we have come to learn to become our actual electronics and telecommunication engineering technician, one of the main topics that you have to learn, how can you identify problems in electronics and the telecommunication devices or system? Right? That's one of the primary. So ask your neighbor, how many problems have you learned about different electronics and the telecommunication system up to this time? Ask your neighbor the number of problems that he or she has identified from different electronics and telecommunication system. Please talk to your neighbor. Can you tell me, come back, can you tell me the number of problems that your neighbor has identified from electronic system or telecommunication system? Huh? She said none of them. And this is the second semester of NTA level 5, second year. And you, what did you tell her? Huh? She didn't ask you, eh? But you asked her. And Binuru, what did your neighbor tell you? Huh? Huh? Neither of them? Many. Example? Huh? School? School. School is a problem. Okay, so this is the list of the 7 steps that you may follow on doing troubleshooting or maintenance of the particular radar system or navigation aid system or some other electronic communication system. So the first one, class, say identify the problem. Isolate the cause. Apply the solution. Test the system. Prevent recurrence. Seek help. Huh? So which one among the 60 do you like? Seek help. Where are you going to seek the help? It depends. You are going to seek your help to the problem. Say identify the problem. Identify the problem. Yafet, say identify the problem. Which problem? So he said that the first step in troubleshooting, the first step in troubleshooting a radar system, we say that is to identify what the problem, because the radar system cannot suffer all the 7 mentioned common problems. It can suffer either one of them or 2 of them or 3 of them. So the first step in troubleshooting and debugging a radar system is to identify troubleshooting and the debugging. Debugging is this is the common computer programming language, which is figure out. When you say that in troubleshooting, we used to troubleshoot hardware system, but we used to do debugging of the software system. Remember that in radar system, we can have preventive maintenance, corrective maintenance, and the system OT, or we call it data OT, software OT configuration. Do you remember that? Yes, so let me write it. So it's the first step of troubleshooting. Say troubleshooting. Say troubleshooting. Troubleshooting and the debugging of a radar system, is to identify the problem, and its source and its cause. We call it and its cause. Problems and its source. Its source, what the source of that problems or its cause. So this is the first step that you have to bear as the technical students or technical engineer. So you should have skills of identifying problems suffered by different electronics communication systems, but also you have to know the cause. For instance, subwriting. For instance, if you go to the hospital, then we explain about the signs and symptoms that you've been suffering. Then the medical doctor actually write the information to the medical laboratory technician. And then the medical laboratory technician will ask you to go and collect it, or actually will collect some samples from your body. Okay? And then after that, he will take those samples and use the medical or biomedical equipment in order to analyze. First of all, to identify the problems. Are you suffering malaria? Yes. What was the cause of the malaria? Oh, there are some plasmodium within your body. Are we together? Yes. Are you suffering UTI? Yes. What are the causes? Okay, there are some microorganisms or bacteria that have actually affected your urine system. Are we together? In case that actually, okay, they are making, they want to take the full blood pictures. That's your blood. Okay, what usual in case of the full blood pictures, they usually compare the number of white cell and red cell. So in case that white cell, the number of white cells is greater than the red cells, then that's what you call to have blood infection. Okay? So the problem is, okay, now within your body, the number of white cell is greater than the number of what? Red cell. That's the problem. And what the cause? Then actual, the doctor or the medical doctor. Because remember that the medical lab technicians cannot tell you about the cause and how to treat it. The medical lab technicians will write a report to the medical doctor. Are we together? So as a serious technical students, don't think that in electronics we are doing something different. We are doing similarly to what actual doctors used to do for our bodies. And in case you have that mindset, I want to tell you that actually we'll be solving critical problems in electronics and telecommunication engineering. Are we together? So for this sentence is actually to identify problem and its cause. This is the general sentence. But again, if I could be you, I could go deeper. How can I identify different problems that affecting different electronics and the telecommunication system? So there are a number of them, right? How can I identify them? And then the next question, how can I know its cause? Because I cannot go to the next step of isolate the solutions or apply the solutions while I don't know the problem. For instance, if you go to the farmers, how many medicine do you find on at the farmers? Many. And then you say, myself, I'm sick, but I don't know and I don't want to go to hospital to identify the sickness that I'm suffering. I just want to go to the farmer and drink all the medicine found in the farmers. Ask your neighbor, are you ready to do that experiment? And if you're not, don't worry about the price or about the, just you'll be given a free offer. Drink all the tablets, all the actual all the medicine available in that farmers. So can you? So that's the first step that you have to do. For the radar system now, for the radar system, the following the following factors can help you to identify the problem. So the first factor, it means that when radar system has some problems, they might give you status. Say status. Say status. Also, you may use something called logs. Logs, this the words just like logbook that you have. So logs may give us some also indicators about that the radar systems has problems. But also another part or another factor that can help us to know the problems is alerts. Say alerts. Alert. So radar systems have different alerts. So when you see this signal, according to the manual, this is indicating something is wrong. Right? For instance, stop writing. For instance, in digital multimeters, when actually the battery of the digital multimeter is about actual to fail to power the digital multimeter, you see the alert, the sign of the battery on top on the display of the multimeter. So that's an alert. For instance, in case of the cars, in case actual that your car is running out of the fuel, there's also an alert. It may be either alarm, or it may be actual that the light emitting diode actual blinking on the dashboard of your car. So all of those are very important. But when you talk about the drivers, actually thinking about what? You're thinking about maybe about just they are not actually more technical. They are just for the driving purpose. Okay, are we together? And also another factor and the indicators. So radar system has different indicators. If we went once we visited the radar system, so the tallest students has gone out. So when we visited the radar sites, we found different LEDs. Some of them are green, some of them are orange, some of them are red. So and some of them were actual, some of them were off. Why? Because for that, once they turn on, they give you some information that something is wrong. Are we together? Class, are we together? Yeah. Yeah. So it says sometimes the duty technician might perform basic tests and measurements. Basic tests and measurements to verify the system. To verify the system. The system performance. Verify the system performance and the functionality. So sometimes it means that the troubleshooting might be done to find or sometimes these problems might happen. You don't get the desired results, but there's not any indicator that actually show you or helps you to identify the problem. So for that case, then a duty technician has to do basic tests and measurements to verify the system performance and the functionality. Are we together? Yes. Okay. So then how you may also understand the signs or the alert. So some of the alerts have been written on the we call it system documentations or system manual or radar manual. Radar systems or most electronics and telecommunication systems, once they have been manufactured, they should be actual, or the manufacturers have to write manuals. So within those manuals, sometimes there are some detailed information that once you see this LED is on or is blinking, then that's indicating something, these problems happen to your system. Okay? Okay? So he said that in the process of identifying the problem, Say that sometimes you might read and understand the radar's manual. The radar's technical manual. The radar's technical manual. The radar's technical manuals to interpret some of indicators and the alerts. So whenever you are doing the maintenance, it's better to have its technical user manual, or if the electronics components is technical data sheet. So this is the actual descriptions about identifying the problem. Say identifying the problem. Say identify the problem. Say identify the problem. Is there any question about that first step, common step that we do? If there is a question, this is your time. Okay, no question. So let us go to the second step. Isolate the cause. So it means other students put strike. Say isolate the cause. Isolate the cause. Isolate the cause. So the next step after identifying the problem, the next step is to isolate the cause. To isolate the cause of the problem. Ask your neighbor what the meanings of isolate, because for some of the students that might be a vocabulary. Ask your neighbor what the meanings of isolate. Yeah? Yeah? I said ask your neighbor what the meanings of isolate. According to your understanding. What do you understand when you hear the word isolate? So the next step is to isolate the cause of the problem and locate the fault or components or subsystem. Separating. Let me just explain before we move on. The human body have different parts. Suppose that this is the whole part, the whole human body of holiness. And then holiness is actual suffering, what? An injury, a leg injury. So holiness experiencing an injury on her arm or her hand. So it means that suppose that this is the holiness arm. This is the whole body of holiness. Or if you actual holiness is actual does not like to be an example. This is my whole body. Okay? And then I'm suffering an injury on one of my left leg. So my left leg it's a 1 or 40. It's a part of my body, right? Huh? So once I go to the hospital, the primary function of the medical doctor and medical lab technicians is actually to identify the problems where the problems are, to identify the part in my body where the problems is located. Jafet, go out for 1 minute. So, it means that I say this is the cooperation between the medical lab and the doctor. Okay? So they be trying the yourself actually to isolate the problem. Where is it located? Is it located on your left ear, on your right ear? Where the problem is located? Because it's not the whole body is suffering. You might be having, or you might be experiencing pains and symptoms throughout the whole body, but it has been caused by one point where there is a infection. Are we together? So the second say, once you have identified the problem that you are suffering, maybe whatever, blood infections, so what was the cause? So once you isolate, so how you can isolate? So we need this part to know, because in case of electronic system, suppose that this is the motherboard of the radar system. And this motherboard is actually consisting hundreds of subsystems. Hello, Anna? Hundreds of 40 subsystems. Anna is honoring. So remember that if, for instance, the radar system experiencing power problem, say power problem. So suppose that in these motherboards, this is just the power system or the circuit or the unity dealing with power system in radar system. So in case that the indicators and the alerts indicating that the radar system or the navigation aids equipment is experiencing what? Power problem. So another responsibility of the technicians is actual to isolate in these motherboards or huge motherboards of the radar system where the power supply is. So these problems is actual located in power supply. These problems is not located in transmitter. This problem is not located in receiver. This problem is not located in oscillators. This problem is not located in actual that low noise amplifier. This problem is not located in just in the mixer 1, mixer 2. So the problem is located in power supply unit. Are we together? Yes. So whether it's a motherboard of computer, whether it's a motherboard of mobile phone, you have to isolate. You have to learn the steps and you have to practice how you can isolate the cause. Because these systems actually, they be training and actually they give you a clear understanding about where should you focus. So this is, okay, so I think that you need these diagrams to remind you about what the means of isolating the cause. So in order to isolate the cause, keep quiet, of the problem, sometimes you may need some specialized tools. Some specialized tools and equipment. Some specialized tool and equipments. Such as, so for this part, it's not just a matter of the skills, but also you need some equipments that can help you to isolate the cause. So to isolate the cause of the problems in radar system, you might need oscilloscope. Say oscilloscope. Say oscilloscope. You might need digital multimeter. You might need signal or functional generators. You might need signal or functional generators. You might need testy probes. You might also need a device, we call it a spectrum analyzer. Spectrum analyzer. Also, six, 7, 8. So go and find some other. I won't mention those 3. Go and find some other 3 instruments that you might need in doing troubleshooting or in isolating the cause. So you say that these instruments or equipments, these are instruments. These instruments are used, so use them. I used it to inspect. So this instrument I use it to inspect and monitor. I used it to inspect and monitor the system signals, the radar system signals and the electronic circuits. So you need this list of instruments to inspect and monitor. To inspect and monitor the radar system signals and the electronic circuits. In isolating the problem, you may also follow, you may follow. So you may follow the system wiring diagram, the system wiring diagram. You may also follow the system schematic or the schematic circuit diagram of the schematic circuit diagram of radar system, schematic circuit diagrams of radar system, and a block diagram. So class, let us reinforce the comprehensions or the understanding of the concept. Class A, oscilloscope. Oscilloscope. How many types of oscilloscope do you have in electronics or in telecommunication engineering? 2. One is what? Digital oscilloscope. The other one is what? Analog oscilloscope. So the analog oscilloscope is like this one. This is the analog oscilloscope. Then the second device is called the digital multimeter. Say digital multimeters. Digital multimeter. You free yourself, Sangodi, and say digital multimeter. Are you active? Say digital multimeter. Digital multimeter. Ask your neighbor, do you have your own digital multimeter? Okay, ask your neighbor to show you. Then say signal or functional generator. Say signal or function generator. Say function or signal generator. Then Jafari yourself say testy probes. Testy probes. Testy probes. And the entire class say spectrum analyzer. Say spectrum analyzer. Ask your neighbor, what is spectrum analyzer? Do you know spectrum analyzers, telecommunication, engineering student? Or you're just enjoying the Dar es Salaam city life? So ask your neighbor, do you know, can you tell me what the primary function of spectrum analyzer? And then I left the 3 that you have to go and seek the 3 instruments or equipments or instruments that we are using in isolating the cause. Then we say that these instruments are used to inspect it, say inspect it, say inspect it, and monitor the radar system signals and electronic circuit. Also, you may follow the system wiring diagram. Say system wiring diagram. For instance, that you wired it from the power source or power bank to the motherboard. And then you took actually another wire from the motherboards to the display. So that the system, that's what we call the system wiring. We don't mean about the house wiring, but the system wiring. Also, you may also check, or you should have, or you may follow the schematic circuit diagram. Say the schematic circuit diagram. Yes, means you may isolate the cause of the problems by using the schematic circuit diagram, for instance, of the radar system. But also another important diagram, because I told you electronics and telecommunication engineering is all about diagrams. So also you may need to refer what block diagram. Say block diagram. Block diagram. So in case of this module, we have covered about the block diagrams of the 2 types of of radar system. So those block diagrams are very important in case of troubleshooting or in case of maintenance. So we did not teach you in order to pass the exam. We taught you in order to apply once you'll be actually engaged in industry or in radar industry. But unfortunately for our Bongoland students, once the exam has been passed, bye-bye block diagram, bye-bye, bye-bye, bye-bye. We'll meet if God wishes. And then you know what the Tanzanians actually just are saying, welcome the certificate, welcome the certificate. Then you may need something to isolate. This is the one of the challenging part or step. You say you may need to isolate. You may need something. You may need to disconnect. You may need to disconnect. Or you may need to bypass. You may need to bypass, or you may need to replace. You may need to replace some of electronics, some of the electronics components, or subsystem, in order to isolate them. In order to isolate them, from their main system. So sometimes you may keep quiet. Sometimes you may need to disconnect or bypass or replace some electronics components or subsystem in order to isolate them from their main system. What does it mean? Listen. To disconnect it means that you may disconnect it, for instance, for this case, you may disconnect it, the power supply from the radar system and then troubleshoot it to find the problems within it. Okay? Yes. Then to bypass, say bypass. Bypass is, listen, for instance, we have a capacitor at this point that is burnt out. And then there is a signal or the electric signal flowing towards the positive terminal of that electrolytic capacitor, and the signal will pass through the capacitor, and its output will be received or will be drawn to some other points. So and then the signal will be taken to the negative to the other part. So for instance, I have a signal that actually from this point and passing through the capacitor. Let's say that this is the capacitor, this is the electrolytic capacitor, have the signal. Because you know some students have never learned about how to bypass. Suppose that we have a signal passing through electric capacitor to another point. So this is the signal from point A, this is the signal from point to point B. But unfortunately this capacitor is no longer working, it is burnt out or it has swelled. So in order to check if this capacitor might be the cause of the problem, then you may bypass. So you may use a jumper or a wire to bypass the signal not passing through the capacitor. That means of bypass. I say that, suppose you have the system like this one. This is point A, this is point B. Then the flow of current. This is the resistor. This is the capacitor. But this capacitor has got some problem. It has swelled, or it is swelled, or it is burnt out. Okay? So if it is swelled or it is burnt out, it can be blocking the electric signal from this point to this point. Okay? So when we have been asking or you are using the trick of bypass, then you may take a jumper to draw the currents at this point C, and we use the jumper to draw the currents at from point C to point B. That the means of what? Bypass. It means we are actually we direct current to flow in the another directions, but not passing through the component. Are we together? Are we together? It's just like in road traffic. So for instance, if the traffic is in a certain point, some of the drivers, they used to bypass them. Right? Yes, they have to use the by roads, safe roads, and then to bypass what? The traffic. That means of what? Bypass. But sometimes replace. So for instance, this capacitor, you may not bypass, but you can replace it with a new one with the same specification. Okay? 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 The aim is actually to isolate, because remember that the radar motherboards is complicated. For instance, this we call it radar trainer kit. You see this one? This radar trainer kit. This radar trainer kit is block diagram. All of this is block diagram. So within this block diagram, this is actual radar signals that will be actually transmitted from one point to another point. This is the scanner unit, and this is the acquisition. This is modulator. This is receiver. This is scan conversion. This is display unit. This is processing unit. This is external devices. This is power supply unit. This is the control panel. So don't think that real systems are easy. So classroom systems are easy rather than the real system. Because for instance, can you imagine, have you ever drawn the block diagram like that? First of all, you have never thought about that. Say isolate the cause. Class, say isolate the cause. Say isolate the cause. Then the third common step is apply the solution. Say apply the solution. Say apply the solution. You have identified the problem. You have isolated the cause. Now the next step, apply the solution. So stop writing, stop writing. When we relate these concepts with the 7 steps of solving a scientific problem, we say the first step in solving a scientific problem is to identify the problem. It's just like in troubleshooting. Okay? The second step, we say the hypothesis formulation. Say hypothesis formulation. So hypothesis formulation, its synonym is isolate the cause. Okay? Then the second step is experimentation. Now perform the experiment. For in case of troubleshooting and maintenance, the second step is called apply the solution. You have identified the problem, you have isolated the cause, then you are a doctor of medicine, you have been learning about how to solve common problems in human body. So apply the solution. You yourself as a technician, as electronics and telecommunication engineering technician, you have been learning technical skills or technical solutions, electronics and telecommunication technical solutions for 3 years, NTA level 4, NTA level 5, NTA level 6. So then we have given you a problem now. Apply the solution. Apply the knowledge. Apply the understanding that you have. So ask your neighbor, what can you apply? For instance, if you have gone to CAA and then they ask us, our radar system has the problems. Tell us how we can figure out. So the third step is to apply the solution. To apply the solution to fix the problem. Apply the solution to fix the problem and restore the system functionality. Functionality and the performance. So he said that the third step is to apply the solution. Say apply solution. Why do you need to apply solution? You want to fix the problem. What kind of the problems? Okay, it may be signal quality, maybe power problems, maybe noise, maybe alignment, maybe calibration. So the solution to fix the problems and restore the system functionality. System what? And performance. You want to restore. So this step may involve. So this step may involve. So this step may involve what? Adjusting. This step may involve adjusting, may involve repairing, and this step may involve replacing the fault component. Replacing the faulty component. The faulty the faulty component or subsystem. Or subsystem, as well as or subsystem. So he said this process of applying the solution may involve adjusting, say adjusting. So you can do some adjustment when it's necessary, or may involve repairing, say repairing. Say repairing. So it may do either simple or intensive repairing, but also it may involve replacing, say replacing. Say replacing. For instance, can you replace your teeth? Your tooth? You can replace it, yeah? With what? With plastic tools. With gold, yeah? Okay. Then the faulty components or subsystem. But again, since this is said that, you may say that this step may involve what? This step may involve the following: recalibrating. Class recalibrating. What problems will be solved when you do recalibrations of the radar system? Class, I mentioned some 7 common problems. Then we are in applying solution. When actually the solution that you are supposed to apply, NEMA, is recalibrating. Which problems are you going to solve? Lillian, tell me. Which problem are you going to solve? Lillian was not in the class. I say one of the solution is adjustment. Say adjustment. Adjustment. Another solution may be repairing. Another solution may be replacing the faulty component. You may be adjusting some components. You may be repairing the faulty components. You may be replacing the faulty components. Those are the solution, 3 solutions, right? But also you have another solution that sometimes you are not adjusting the radar components system, or the radar components. You are not repairing. You are also not replacing. But you are supposed to recalibrate. So the question now, in case of recalibrations, what problems do you think that he will be solving? Go back to the 7 problems you have forgotten already while you are still in the class. Issue. Calibration is problem number what? Number 3. So radar system and navigation aids might have a problems of what? Calibration. So to figure out or to fix the problems of calibration, we have to recalibrate. Right? We have to do what? To recalibrating the radar system. But also we have another problem which you have mentioned. I am trying my level best to make sure that you understand this concept. So another solution, you may actually applying the solution, you call it realigning. Realigning what? Radar system. So what problems are we going to solve if you are applying the solution of realigning? Alignment. Understand? Okay. Then we can have another solution that we call it in radar system resynchronization. 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 Say resynchronization. No, I think resynchronizing. Resynchronizing. So another solution is called the synchronization. Synchronizing. So this solution will be the solution of which problem? Okay, good. Synchronizing the system parameters. System parameters and settings. System parameters and what? And settings. So this is in case of the hardware part. How about software part? What solutions may you apply? The possible solution for the software problems are: the first one, you may update the file. How many times did you update your computer? Update the system software. Update the system software. Say, update the system software. Upgrade. Update the system software. That's one of the solutions. The second solution, you may upgrade the firmware. May upgrade the firmware. Firmware. Say firmware. Say firmware. What is the difference between application and firmware and operating system? Gratitude? What is the difference between firmware, operating system, application? You said you're expert in computer. Or in some other areas. Then also, software, you can do, or we can do some security configuration. Say configuration. Say configuration. Configurations of the files. Configuration of the file. Another possible solution that can be applied for the software to ensure what? To ensure compatibility. Say compatibility. Say compatibility. Another possible solution for the software, you may ensure stability. Stability of the software. So you must follow the system procedures, the system guidelines, and safety precaution. And the safety precautions to apply the solution to apply the solution correctly and safely. Hello? So this is very important sentence. The issue is not to apply solution. Stop writing, my students, my dear students. The issue is not to apply the solution. Sometimes, in the middle of your process of applying the solution, yourself, you may cause another problem, or you may experience a problem. That's another challenge for the electrical system. Let me repeat. You know that sometimes a medical doctor, in the process of rescuing somebody alive, he or she may get some effect. Do you agree with me? For instance, during the COVID-19, if for instance a medical doctor does not take a lot of precautions and he or she usually treat maybe the COVID-19 affected people, maybe 100 people in a day, do you think that he will be alive? Yes. I say the medical doctor who did not protect himself or herself when he or she is actually treating people who have been affected by COVID-19. And actually the number of people in that hospital, one doctor maybe actually has to treat 100 people. So do you think that the life of that person who is applying solution won't be in danger? Will be in danger. Right? But he'll be in danger while he's trying and fighting to rescue somebody's life. Similarly to you as a technician. You'll be struggling and using your knowledge, you want to rescue the radar system to work, to come back to life. Right? But in between, yourself, you may be affected or lost life, or you may destroy some parts which have no any problem. That's why we say that technical maintenance it's not easy. It's not just something that you sleep, you wake up, just you encounter the device, then you maintain, so you fix it. No. That's why we say that we are warning all the technicians. You must, say must. Say must. So this is the command sentence. You must follow the system procedures and also system guidelines and safety precautions to apply the solution correctly and safely. So having the solution is not all. How you can apply that solution without affecting some other system or without affecting yourself. Okay? So it's still a challenge. You may have 100 solutions, but if you don't know the safety and precaution, you apply one solution, you cause 3 problems. That's the goodness of electronics and telecommunication. You apply one solution, you cause 5 problems. So after time, when the clients or the owner of the systems come back, you say, oh, my brother, I'm very sorry. For me, I have failed to fix the problem. So send to some other technicians. Or actually, they can tell, I think that I know all the technicians in Dar es Salaam. Nobody who can solve this problem. So my advice, just prepare the budgets to buy the new one. So once the technician said that maybe the system had 1 problem or 2 problems, but because of the ignorance, he or she has caused some other problems along the applications of solution. Because sometimes your intentions is not to cause problem. Right? The intentions of the medical doctor is not to die while rescuing somebody alive. The intentions is actual to rescue himself, to be alive, and the patients also to be alive. Your intentions also is actual to rescue that part, but also some other parts to be safe. Class, are we together? Yes. In engineering, we used to say that safety is above all. Say safety is above all. Say safety is above all. You may not know how to, you may not have even any solution, but if you have safety, you are protected, and actual, you will be enjoying engineering. Students, is the concept clear? Yes. Now it's a time I want to give you a chance to ask you questions. Hamza, do you have a question? Hamza, do you have a question? No. Ashura, do you have a question? No. Geoffrey, do you have a question? No. Sierra Lillian, do you have a question? Did you understand first? What did you understand? So which one did you like among the three? The first one. Identify the problem. Do you use to identify problems or do you use to cause problems? You used to cause problems. Comba, do you have a question? Awase, do you have a question? Matthew has escaped there. He ran away. And the tallest students also ran away. That is good. So they ran away while I didn't end the class. I like those students. Ostaz? Yes. Do you have a question? No. Eliza, do you have a question? No. Anna, do you have a question? Faith, do you have a question? Nema, do you have a question? Nema. Nema, that one. She doesn't have a question. So if you don't have a question, I want to tell you that go. Now the tallest student is back to the class. He just came up to finish the class. Okay, listen. Hello, attention. You might take this information light or easy, but I want to tell you that these are very important technical information. I've just introduced you those 3 steps. What I would like to ask you, please make sure that you go and learn in detail. And even you can learn how you can troubleshoot one of the systems that you're interested with. Because once you have a particular system, you may know its common problems and what are the useful tools. Because remember the title of lecture 11, common steps, which I've been discussing, and the common tools. That's why you mentioned spectrum analyzer, that's why you mentioned dictoscopes, etc., etc., etc. So this is my request for the rest of your life in electronics and telecommunication engineering, even some other related fields. I want to ask you that make sure that you go further and further. And if I could be you, especially for the technical students or technicians, I could have a strategy that every week I have to learn something about maintenance or about troubleshooting. Because that's the great business that we are doing in our own country, especially that actual a small because in our country electronics is not in a wide space. Are we together? So let me leave that as a challenge. You can just have a strategy, 1 hour in a week. I want to tell you that after a year, you'll be my teacher. You'll be teaching me about maintenance and be teaching about troubleshooting because you've gone far rather than myself. So if that's the case, my dear students, I would like to say it is the end of lecture 11. Thank you very much. In case you have a question, don't hesitate to ask in the comment section. In case that you have something that we did not discuss, please make sure that you share with us in the comment section. Remember that what I've taught is just a small portions of the knowledge and skills and understandings about maintenance in electronics, and especially for the radar. As I said usual, I don't know everything. That's the small portions that I know. So I would like to hear from you and also to learn from you. So if that's the case, this is the end of lecture 11. Welcome to the lecture 12. We'll be discussing about 3 common steps and some common tools that we are using to figure out. So the assignment that I'm leaving to you, just to go identify some other common problems in radar system and identify some other common tools which are used to figure out. You may either use the internet or you may either consult somebody or radar expertise to tell you, because that actually will take you to the next stage. So if that's the case, now it's a time, let me just confirm about my students, if they have understood the concept, and then I don't have jealous to my students, I congratulate them. My students, did you understand the concept or you are chatting? You understand. Thank you very much. I thank God. If you have understood, keep what you have understood, because understanding is one thing. Keep what you have understood and apply it in your daily life. So now it's a time to congratulate you. Quickly. Increase the speed. Jafari. 1, 2, 3. Hongera. Imara. Wow. Thank you very much. See you in lecture 12. Bye.
Mungu ibariki Tanzania, dumisha